Yay, we're live. Okay, this is Math 75, section 2.3. This is business applications using quadratics, page 1. And just for the heck of it, let's say this is my very first take. Why don't we just say it that way? But this is going to be the best take. It isn't necessarily the first one, but it's the best one. This one we're going to keep unless I trash this one too. I may end up making this video 400 times. We will see. Hopefully it's getting better every time. Okay, so we've got applications using quadratics or parabolas, basically x squared. And the first one we're going to do is a profit function problem. And as usual, the book has written out profit with the leading term in the middle. So I'm going to go ahead and pull that out, the x squared term, right here. And then I'm going to look at what else it says. It says we've got a profit function. It says limitations on space require that production is restricted to fewer than 75 units. Remember that X is the production. Y is the profit. Why? Because we love you. So X is the production. It's the number of units of production. So what this is telling us right here, the production is restricted to fewer than 75, means that X has to be strictly smaller than 75. Okay, let's see what else it says. Then it says find the break-even points. Remember that break-even are when you make no profit. So in other words, P of X is 0. You can also talk about break-even points being when revenue equals cost, but since we don't have revenue or cost listed explicitly here, that's not as useful for us. Okay, so we look at these three things, and I think the thing that makes this problem hard is that we have this formula, this equation. We've got this, which if I'm going to be a fancy math teacher, I would say this is a restriction on the domain. Or the other way to look at it is X just can't be anything bigger than 74. And then we also have to set P of X equal to 0. And so we've got these three things in motion. And so it's hard to know where to start. And what I will tell you is from all my vast, vast decades, going back to the 1730s in math, is that when you have a restriction on the domain, when I tell you X is limited, or even that Y is limited, you deal with that last. What you do is you pretend that doesn't even exist and solve the problem without it. So I'm going to go ahead and just focus on the break-even points. You know, those points when we're not making a profit for whatever reason. Maybe we're in perfect competition. Maybe we're just looking for some boundary values. So when the board of trustees says, hey, what's the minimum or the maximum number of units we could make, we could actually give them a range. There's a lot of different reasons we might look at these break-even points. So I'm going to set it up. Here's my equation. Set it equal to 0. And then I'm going to say there are many of you watching this who are brilliant at factoring. This one does factor, so factor away, you know, hit it, go get them, Tiger, all that. For those of us who look at this and see decimals, 0.1 and 11.5, and we're like, that's a hard limit for factoring, Bob. So what I'm going to do is I'm going to go ahead and use the quadratic formula. Quadratic formula will always be there for you. Regardless of what else is going on, the quadratic formula will work. It might not be fun. It's not the nicest, maybe healthiest love, but it does love you. Minus 4ac. I should be saying this all out loud so you guys can hear it. The opposite of b, plus or minus radical b squared minus 4ac all over 2a. Woohoo. In this case, I've got a equals negative 0.1, b equals 11.5, C equals negative 150. Okay. Woohoo. Let's do some math, guys. Yay, math. So I've got negative 11.5 plus or minus. Now, here's where I'm going to try to change my ways. I'm going to give myself a really big radical. See if this is big enough. Okay, I got 11.5, the quantity squared, minus 4 times negative zero point 0.1 times negative 150. Bam! Look at that. That is perfect. That is beautiful. I really hope that this take is the one that I keep because otherwise this will be lost to history. This is the one time I've actually given myself enough room in a radical. This is very exciting for me. Okay, so this nightmare is the calculation we have to do. And again, I would encourage you to use a calculator. It's really easy to make mistakes, especially with a lot of decimals running around. So let me see if I can start to approach this bad boy. 11.5. Ooh, calculator needs to be on. Helpful professional tip there. Calculators work better when they're on. 132.25. Now, if you're going to multiply all these together, I'll remind you that these guys that are negatives, they're actually signs, not subtraction. You need to use a special key on your calculator. On this calculator, I don't know if you can see it, it may be a little bright. There's this guy down here, which is a minus in parentheses. That changes the sign. Some people have a plus or a minus. The important thing is you cannot use these. This is strictly subtraction, and a calculator is not smart enough to see how these are related. So it will just barf at you if you do it the other way. The other thing you could do is say, okay, I got a minus and a minus and a minus. So I got 3 minuses all multiplied together. That's going to give me a negative. And then you could just multiply the numbers. 4 times 0.1 times 150 gives you 60. All over negative 0.2. In the home stretch. This is very exciting. I'm very excited. I hope you guys are very excited. I can feel it through the camera. You guys are all like, yes, this is awesome. I can't wait to learn more math. And I'm just going to limit you to this much math for right now. Just you know, we'll learn some more later. I know Spider's always present, cheering us on. Yay, you're almost there. Okay, I got 132.25 minus 60 gives me 72.25, which I, on my handy dandy calculator, can tell you is 8.5. Now, again, this looks like it's just kind of like a nightmare. But in fact, it turns out this works out really beautifully because what we get is we get negative 11.5 plus 8.5 all over negative 0.2, or 11.5 minus 8.5 all over negative 0.2. And rather than doing this on a calculator, although I could easily, I'm going to go ahead and do this just in general. Negative 11.5 plus 8.5 on a calculator or in your head will be negative 3 all over negative 0.2, which gives me 15. Put an X over here in case we've forgotten these are all equal to X. Over here, negative 11.5 minus 8.5 is equal to negative 20 all over negative 0.2, which gives me 100. So my two answers are, I'm going to use the space over here, X equals 15 or 100. But wait, I'm not done. We then go back up to the top and we say, wait. X has to be smaller than 75. It would be really awesome to have a great, big, brand new facility and be able to make as many of these burritos as we'd like. But we can't. So I'm going to cross out the 100. And believe it or not, let me write in my units. Believe it or not, this is the correct answer. The correct answer is actually 15, 100 with 100 crossed out. So you're acknowledging that under normal circumstances, we'd have two options because, again, remember, when you've got a parabola, we're going to have 2 points where the parabola is equal to 0, 2 break-even points. This is X. But it turns out that we are limited. We can't actually achieve the second one. But maybe that's maybe this is your opportunity to request a some sort of a loan. The Board of Trustees think about actually using some of the money they've saved up to build you a better facility. Shiny new burrito tongs. I don't know what you would get for burritos, but you know, tortilla. Ooh, shiny new tortillas. Nice. Okay, so I will be right back with page 2. I know, the epic conclusion to the epic story, business applications using Quadratics.